Hello everybody, today we're going to start section 9.4. It's your last section in chapter 9, so keep looking ahead for reviews for chapter 9 and then you will be having a test coming up, which will be given on Schoology. So what we're going to do in 9.4 is solve equations just like we did in chapter 8, only now we know more identities, so we may have to apply those identities before we start solving these equations. So first I'd like you to pause here and read through these 7 steps. You can fill in the blanks with the bolded words here if you printed out the notes packet. Otherwise, I would just make a list of these and have them handy so you have a list of strategies in order to use as you're going through your assignment and then also as you take your test. All right, so now that you've read through those 7 steps, or 7 strategies, let's go ahead and get started. So first things first, we're going to look at this example, sine of 2x plus cosine of x. This one, it looks like these have different frequencies, right? This has sine of 2x, this is just cosine of 1x. We do know, though, when we have a frequency of 2, we can apply a double angle identity. So if you take a look at your formula sheet, sine of 2x is going to be equal to 2 sine x cosine x, and then plus that cosine x that's already there equals 0. Now, the nice thing about this is we can see here both of these terms have a cosine of x in common. So we're going to use our strategy that we've used previously of factoring that out. So we're going to factor out a cosine. Let's get it on the right pen here. There we go. So cosine of x, factor that out. So that's going to become times 2 sine x plus 1 equals 0. Now, when you have 2 factors equal to 0, you set each factor equal to 0. So cosine of x equals 0, and 2 sine of x plus 1 equals 0. Now we can use our unit circle. Cosine of x is 0. Now our solutions have to be any solution in the first period, 0 to 2 pi. So cosine of x is going to be 0 at pi over 2 and 3 pi over 2. And then 2 sine x plus 1, if we subtract 1 and divide by 2, we get sine of x equals negative 1/2. And if you refer to your unit circle, sine of x is equal to negative 1/2 at 7 pi over 6 and 11 pi over 6. All right, so that one should be relatively straightforward. Let's try a different one. Now, this one goes along with the strategy hint number 4. So when it says make sine of x and cosine of x into tangent of x, you have to make sure the frequency is the same. So with these ones, as you can see, you can tell these both are double. And right away you would look at this and probably think I want to use a double angle identity, but that's not going to help you because if you look at your double angle identities for sine and cosine, you're not going to be able to necessarily factor something out in common from all of them. You're going to have a mix of sines and cosines and not be able to do much with it. So if you have an equation that has sine and cosine and they're both double angles, their frequency is the same, what you're going to want to do is actually turn them into tangent, and here's how you're going to do that. What we're going to do is add this cosine of 2x to both sides. So you get sine of 2x equals cosine of 2x. Once you get that, then you're going to divide everything by cosine of 2x. When you do that, you get sine of 2x over cosine of 2x on the left, and then you get 1 on the right. Now, this is what we mean by turning it into tangent. Sine over cosine is tangent. And since it's sine of 2x over cosine of 2x, this is going to become tangent of 2x equals 1. All right, so since we have tangent of 2x, we're going to go back to our chapter 8 strategies. We're going to use some u substitution here. So we're going to say u equals 2x So we're solving where tangent of u equals 1. If you refer to your unit circle, tangent is 1 at, from 0 to 2 pi, pi over 4, and what is that other one? 5 pi over 4. All right, now, since this frequency of 2 changes your period, to get all of the solutions in 0 to 2 pi, we're also going to have to keep in mind that these are actually plus pi k, and you'll see in a minute why we mean that. So 2x is going to equal pi over 4 plus every period of pi, and 5 pi over 4 plus the period of pi. Now the reason we're doing this is because to get x, the measure for x, we have to divide everything by 2. So x equals pi over 8 plus pi over 2k, and x equals 5 pi over 4 plus pi over 2k. Now the reason we wanted to do this is because we need to list every, not 5 pi over 4, 5 pi over 8. There we go. Plus pi over 2k. Forgot to divide by 2. All right. Now, the reason we need to keep in mind our period here is because we need every solution in 0 to 2 pi. If we just list pi over 8 and 5 pi over 8, that only gives us up until basically just past pi over 2. That only gives us our solutions in the first and second quadrant. Okay. So what we're going to want to do is keep adding pi over 2 until we get up to 2 pi, which in this case would be, if we're over 8, 16 pi over 8. Okay. So if we had pi over 2, that means if we think of everything in terms of common denominators, we're going to be adding a 4 pi over 8. So x is going to be pi over 8. Plus pi over 2, or plus a 4 pi over 8, is going to be 5 pi over 8. Plus another pi over 2, or plus 4 pi over 8, is going to be 9 pi over 8. And then plus another is 13 pi over 8. And then if we added another, we'd get to 17 pi over 8, which is over 2 pi. So you don't need to worry about that. Okay, so that's why with tangent, anytime you're dealing with tangent that has a different frequency other than just 1, you have to take into account the period of that. Only with tangent. Okay. All right, next example. Find all solutions in 0 to 2 pi for this, what looks like is a monster, but let's just think about this here. So 2 sine squared of x over 2 times 1 plus cosine x. So as you look at this right here, the sine squared of x over 2, right? That's a half angle identity. The half angle identity for sine of x over 2, let's write that out just so you can see, is going to be, there's a 2 in front of it, so we'll leave that 2 there. So 2 times plus or minus square root of 1 minus cosine of x over 2. Now that's just for sine of x over 2, but we have sine squared of x over 2. So then we have to square that. All of that times 1 plus cosine x equals 0. Now the nice thing about this, since this was the half angle identity squared, it just basically cancels out the square root. So this is really just 2 times 1 minus cosine of x over 2 times 1 plus cosine x equals 0. 2 times something over 2, those 2's will cancel, so we're left with 1 minus cosine x times 1 plus cosine x equals 0. Now, since we have 2 factors equal to 0, we just set each factor equal to 0. So 1 minus cosine x is equal to 0. 1 plus cosine x equals 0. So this would be cosine x equals 1 and cosine x equals -1. So we're looking where cosine x is 1. So that's just going to be at pi. And cosine of x, excuse me, I got my numbers mixed up here. Cosine of x is 1 at 0, positive 1, 0 and 2 pi. And then cosine of x is equal to negative 1 at pi. So our solutions here are 0, pi, and 2 pi. So even though this looked like it was kind of messy, since it's a half angle identity squared, it actually works out pretty nicely because it'll just cancel out that square root. All right, last example for this day of 9.4. So cosine of x plus 2 minus sine of x. So as you can see here, we have a cosine of a sum. So we're going to want to apply our sum identity or our addition identity for cosine. So let's do that. So cosine is cosine, cosine, sine, sine, sine. So it's going to be cosine of x, cosine of pi over 2 minus sine of x, sine of pi over 2. All of that minus sine of x is all equal to 1. Now let's simplify our addition identity here. So cosine of pi over 2 is 0. So this becomes cosine of x times 0 minus sine of x times sine of pi over 2, which is 1. And then all of that minus sine of x is all equal to 1. All right, cosine of x times 0 is 0. So we get a negative sine of x minus sine of x equals 1. These are like terms. So we have 2 negative sine x's. So negative 2 sine of x equals 1. Divide by negative 2, we're looking where sine of x is equal to negative 1/2. Sine of x is equal to negative 1/2 if you use your unit circle at 7 pi over 6 and 11 pi over 6. So you should notice with all of these that we're basically just adding on using the new identities that we've learned. The strategies once you get to that point are very similar to what we've used before. So after this, try practicing a few of these using the 9.4 worksheet. If you need to go through these examples on your own again, you can try that. And then just make sure you check out the daily task because that has to be completed for engagement and attendance. Have a great day.